Okay, here we go. I think we're on round 3 now. Hopefully we get it right this time. Motor. You've got 2 of in your tank. One of them drives the left side, one drives the right side. If we want to switch it on and off, you're going to need some form of switch. Now let's look at what happens if you just have a normal manual switch. A normal manual switch, you close that and you will connect the 5 volts to the ground via the motor, which means current is able to flow down here. I is the symbol for current. Current flows down. It means current is flowing through the coil in the middle of the motor. That generates a magnetic field which interacts with the magnets inside the motor and causes it to spin. That current will be the same way through the coil all the time in the inside the motor, which means the forces are going to be the same way, which means it's going to spin the same way around. It's not very helpful for your remote control car. However, it's all good for a line bot which just drives forwards and does not have to go backwards. Now, we're going to need an electrical switch because we are wanting remote control. We don't want to be stood on top of a remote control car switching it on and off. So we have to replace this switch here with a transistor. We are going to use an N-type in here. N-types have the arrow at the bottom like that. That is an electrical switch. To turn it on, put 5 volts here. To turn it on, and to turn it off, 0 volts. Just like that. Your Arduino has the ability of outputting 5 volts or outputting 0 volts. Or it can do like a pulse signal with your PWM to turn it on a little bit. Talk about PWM another time. That's all good, but you can't go backwards. To go backwards, you need an H-bridge. This is what an H-bridge looks like. Put the motor in the middle of the H. You have a switch, a switch, a switch, and a switch. We're going to call them A, B, C, D. So you've got 4 switches. That's why you have 4 transistors. If we connect A plus D together, then the current's going to flow, isn't it? So this is your 5 volts. That's your ground down here. Current will flow down here. If we turn A on, through the motor, D's on, it's going to go down there, isn't it? Yep, that's all good, and the same as that. So you can get it to turn clockwise, can't you? Or you could call it forwards. Whichever. It's going to work. If we wanted to go the other way, we're going to have that one open. Shut that one. That one needs to be open. Get rid of that. Get rid of those. So you'll need B plus D. So it's B plus C is going to be the other way, isn't it? So if you connect those ones, shut those switches, current can flow this way, this way, this way, this way, this way, this way down to the ground. So it's going to go the other way. And oh yeah, all good so far. It's great not having any questions. All right, so we get rid of those. What happens if you shut B plus D? That's probably not very good, is it? What's going to happen? Current can go down here, down here, down here, down here, to the ground and potentially melts everything and everything goes up in smoke. It's called a short circuit and it's not good. Don't do it. Okay, so how do the transistors go in here? Let's change these switches to transistors and see what we can do. Remember, these N types that we talked about before are underneath the motor, so they are switching the ground. That means that these ones here need to be N types. Wow. D, C. Okay. The P types can switch the positive. Those that are into music, this sort of arrangement is needed for an amplifier to work. You'll notice that the arrow is in a slightly different direction, or place, I should say, on P type from the N type. So this is a P type, that is an N type, the same over there. So this, go like that. Draw it the other way, it's better if we draw it the other way. You'll see why in a second. That's B. So the same rules still apply. A plus D will go clockwise, B plus C will go anti-clockwise, and B plus D is not good and we don't do that. Right, what are we going to do? So to turn these ones on, the N types, you need to apply 5-volt switch. Okay, so that can go to the pin on an Arduino, and that would go to a pin on the Arduino. So if I was doing this, I'd probably use like pin 11, maybe pin 13, whichever pins you're using. You try and use the ones with a squiggle next to them because they have the ability of outputting a PWM signal. This one, you need to put 0 volts on to turn it off. Because they're a different type of transistor, they turn on and off with a different current, different voltage, sorry. So if you put 0 volts on here, you'll turn it on. So if you put 0 volts on here, then a little bit of current will flow this way, down here, and out through there. That allows a large current to flow through here and through the motor. How are we going to put 0 volts onto those? Well, you could get one of your Arduino pins to write to it with writing a digital write-low signal to it. But it's not actually the easiest way of doing it. The easiest way is a little cheat. If you take this wire here and you connect it to there, we normally put a resistor in there. You don't actually have to. So if you connect that through to there, what happens? When you turn this one on, this is connected to ground, remember, which is 0 volts. When you connect that one, when you turn that one on, this wire here becomes 0 volts. That means that wire there is 0 volts. This wire here will be 0 volts. And the transistor will now read it as 0 volts and turn on. We can do exactly the same on the other side. Like that. Now those resistors are quite small. They are the ones which go diagonally across on your breadboard, and they are something like 50 ohms or 100 ohms. It's not quite the end though. This pin here, you normally put, some of you have done this, another resistor in here. So that will go to your pin, off to your pin, but down here, we will put another resistor in and tie it down to the ground. Why do we do that? Well, we do that to make sure that it's turned off when we want it turned off. These resistors are at least, so those resistors are at least 10 kiloohms. Okay, these resistors here, those are the diagonal, and they're generally about, what do we say, 50, might be 100 ohms. So they're very different, those resistors. Now, in the next video, we're going to talk about capacitors, which I don't think any of you have got, and possibly the need for having some diodes in there. But that's for another time. All right, thanks. Bye.